And our first keynote today is Annabelle Feng from Purdue University. Annabelle.
Can we without this, right? I'm normally very loud. Yeah, so I'm giving this talk on behalf of Stuart. He really wanted to be here and he wanted to send the greeting, but he had some very unique emergent family situation taking him to London instead of Dallas. And this is great for me because now I have 45 minutes to talk about what I want to talk about. Right? I want to talk a little bit about Suresh Sethi because everybody knows I'm one of the earliest students Suresh had when he started UTD. And it is not easy to be Suresh's student. That's for sure, right, Anshuman? Because when you
Sorry. It gets easier after you graduate.
okay, we'll come on that and you can actually, okay. So when I came to Texas the first time from a whole other country and have nothing to do, no idea what PhD program is about. So what do? You go on the website, look at faculty profile and say who I want to work with. And then you read papers, right? And you go and meet with each individual faculty and then you read papers. When I get to Suresh's website, I was completely lost. How many papers he has published?
400. Now, 400 now. When you joined, 200.
It's already 200.
Yes, I counted it's actually over 500. I have 529. I'm counting the proceedings and publications and publishing rules and then
I've not read that many papers.
when I have days in your life.
So that's the first thing. On day one, I started a habit of extensive reading because of Suresh. Because you want to know what your professor has been working on, what expertise he has, so that when you go and meet with him, you don't look like an idiot, right? And so I started working with him, and after finishing 2 papers, he told me, he said, now you should work on something in OM. And I read all of these topics that he has been publishing, and he's very, very broad. And then I realized not all of them are, actually a lot of them are not OM. Okay, and he gave me this inventory book that said, now you should study inventory. That's my journey. Second thing with Suresh as an advisor is that, I have been in the business school, and most business school professors really provide, right? All of us have taught enough so far. And if you're teaching an MBA student, having a class discussion, someone raise hand and give some comments nonsense, what do you respond? That's an interesting point. But we will, but that's not Suresh. Okay. So I remember the first project was on software development. And he gave me this problem that I looked at it, and then I went back and did all my analysis. And I went to his office and showed him my analysis. He looked at it and said, you don't know that I'm a program. You're supposed, you should go and study. And as a student, he's very straightforward. You feel a little bit frustrated. I said I'm a program. I didn't know that I'm a program. Okay. But then over time, when you get to know Suresh, you know that that's how he talks. He tells you exactly what you think. If he says, I don't know what you said doesn't make sense, he meant that particular statement I meant. He doesn't mean personal. And he's still going to, and he's not shy of crazy people. So every time he says, I like this or I don't like this, he meant that exactly. And he never take it personally. And a lot of times, we tend to over-interpret when Suresh doesn't like me, so it's me kind of stupid. But that doesn't work with Suresh. Okay, he's very truthful to tell you what he thinks, and if you really get to know him, I find it's very easy to work with him because I don't have to guess or thinking about, what Suresh really implies when he talks about that, what is he about.
Let me go back to that story that she mentioned. We had this problem. So we were working on software development and it did something. So I remember sitting on a table in my office and I actually showed her the dynamic programming steps. This is how it goes. And now we did it. And then she goes, I was just awesome.
Annabella, of course, when he talks, it's very strict. You can understand it. But how about his handwriting?
Over time, I learned how to do that. But I had other co-authors who like to handwrite, okay? I would say George has the best handwriting, and Suresh is definitely not in the bottom. I've seen much more difficult ones. Yeah. Anything else? The other thing is Suresh has a high standard. I remember there was one paper you probably really recollect because this happens quite a few times. We get review reports and I'm working on, as a student, you want to have publication, you want to finish it off and then you can get on market. And in addition to review reports, he will have new ideas, say, hey, we should add this and do this. So, and then as a student, you say, he's having more work for me for completing the paper, but in the end, I think, I was picking those up. You want to do your best, and anything you see, you don't want to leave it. We're not writing papers just for satisfying the referees. We're writing it for, our own fulfillment and happiness. All right, so, I'm sure you have anything to add.
You're spoken on it.
Okay, I have, because if I can take all 45 minutes to talk about Suresh, but I still want to get to what George wants to talk about. So I think I learned a lot in the last 25 years since I know Suresh. And one thing, in addition to academics and research and how to conduct research and how to think about research. One thing is being a student is really a luxury in the sense that you never need to wait for your advisor's feedback because every time if I have any little write-up, send it to him within 24 hours. He will have the handwritten remarks. And then he will say, come and let's discuss. And being, after graduating in almost 20 years, being an advisor myself, I know how difficult it is to be able to do that. But Suresh has always been every single time, consistently giving us, I think Angelo will agree, within 24-hour feedback. That is itself is extraordinary. I think. And that also shows that he clearly cares about his student co-authors and he takes care of them. He's, especially in early career, you're waiting for getting things published for 10-year promotion and those quick feedback are really, really important.
If I want to say a little bit about our relation with Aaron.
I'll leave that to you. Okay, and I think that is really, really unique because over the years I have many co-authors. I will say that Suresh is the fastest in responding to giving feedback. Okay, so far nobody beats you. Not even close in terms of that.
So it's like when we get up to 100, like 5 days before we were celebrating his 100th birthday. Every time I write to him, even though he was 90, he would reply right away. And I said, sure. He said, I replied to that, I don't know whether I will live to reply to you again. That reply right away to you.
And the other thing being a student, He never talks about it, but I know when I was on job market, he's probably more anxious than me because during my job interview trips, I realized that Suresh is calling everybody, bugging everybody, and talking about me. And I think, again, being an advisor myself, I know that I cannot to do that extent, and he did that for me. I really appreciate it for the rest of my.
And then the third only.
He never shared any of these with me, but I knew that you did that. Yeah. And I want to be a little bit more structured on things. Okay. Next thing, if you look at what Suresh has been working on, he's all over the place. Okay. So that's why at the beginning, when I started reading his work, I get confused what exactly is OM. But in the end, it doesn't really matter. Right? We do whatever we like to do. And that's one thing I learned from Suresh. You get excited about anything, a research problem, a hobby, a topic, you go ahead and explore it. And many of us know that he also is reading very extensively. So when I was a PhD student, and he is, I think you were reading Mo Yan's book, one of the Chinese author, Nobel law.
Before he won the Nobel Prize.
Yes, before he won the Nobel Prize, he was actually reading that guy's book. And we had a lot of debate about that. And Homie probably knows what I'm talking about. And Suresh read a lot.
Yeah, sometimes I disagree with him on that group, sort of the reading as well.
Yes, okay. And even the classical Chinese, if any of the Chinese will know the Siddhartha too, and he look at the translated version and then discuss, three kingdoms, I remember. And of course, we have a lot of disagreement. And then a lot of time the conversation will be ended with Suresh telling me, you don't know China. But anyway, okay, again, we do not take Suresh's comments as a judgment. He just meant what says what he meant, okay? And that also make me think that, as a scholar, we should be open-minded and open to different ideas, different things. And I did not have that of the wide interest of reading before I came to a PhD, and it's only because of Suresh. I feel that I would like to be someone like that and knowing a lot of different things as well, not only for my career research, but also other aspects. So he will be, discussing with you on politics, history, culture, many different things. Of course, he travels a lot. And I think overall, he's a very open-minded person. And I seldom, I think I never heard him making any judgment on people or things. So I think that is a very, very unique trait for Suresh that, I met many people who are open-minded on something, but not to the extent and the level Suresh is. And the other interesting thing is that, yesterday Claire talked about Suresh always being young, and that's also the other aspects of it, because I remember when I was a student in UTD, that's when all these social media started getting popular. And the previous week, he was complaining to me about girls spending too much time on was prior Facebook, something else. Yeah, some space. Yeah. And then later, very quickly, he himself figured out Facebook. And then he said, you should get an account too, and I did. And in the initial stage, you don't have that many friends linked there. So what happened is every time I open Facebook, Suresh photos right on the screen. So if I want to look at Suresh's, what new photos Suresh is taking, but Facebook, okay, because I only have a few people linked there, and most people were quiet. And he just wiped out the screen. So I log into, I have a Facebook account only because it's starting with a place to share his photos. And later on, and he doesn't stop there, right? And you'll be amazed that, people at this age, like my parents, they don't do these things, okay? But last year when I was in Dallas, he's showing me his record of playing with Duolingo studying Chinese. Okay, and what else? Oh, YouTube now. So you can see that he knows how to enjoy himself and enjoy life and finding things that, he's willing to invest time and be happy about it. And he keep going at a speed that I think I won't be able to follow because I've never posted anything on YouTube so far.
I have the time for it.
Yeah. All right. Anything else I want to say? Okay. The other unique thing about open-mindedness of Suresh is that, most of us will have friends that come from our student days, professional life, and maybe a few neighbors and family. That's it. And if you look at Suresh's friend list, if you go on any of the social media, you look at who he's linked with, okay, how did he get to know all these people? And one of the things about him is that I think he shows understanding and he communicates with everyone and he's willing to listen and show sympathy. I think that's also a very unique thing about Suresh. And overall, I would say that the most important thing I learned from Suresh is how to be a happy person. And he is very confident about himself and he's happy about himself, but he's never shy, like, Hassan said yesterday, to compliment others. And he will say, Alana is better than me in solving these type of problems, even though he himself is already a very prominent scholar, but he's not shy to make this statement. And as a student, I remember there are times when we discuss problems, I discover something new, and he will compliment and say, oh, you know better than me on this. And at that time I was, second year student hearing this from your advisor, you feel very humbled and surprised that at his level he's, giving comments like that. And I think that's only a reflection that he's very confident and he tells what he genuinely thinks. And he recognizes everyone for who they are and what they are good at. And so we are business professors. I don't know how to write poems, but this is what I feel about Suresh. We only write academics, right? And I think the most important one is the second one. Suresh is Suresh. He is unique. He is defining someone that, you cannot find anybody saying that similar or close to him as a person. Anybody want to add something?
I want to add something.
Yes.
Years ago, we were in lunch, but package lunch on the third floor, and we were having lunch. And there was some discussion, and Suresh said something, and we said, oh, you'll be jailed for it. And he said, if I go to jail, I'll finish my books. If we go to jail, that was an opportunity for him to do something new.
Yeah, so wherever he is, he will always find a way to enjoy himself and do something useful and meaningful, right? And whatever he does influences people, just like, even when he get on YouTube, it's not in a Islamic community, but he quickly get followers and who finds value in what he does. All right. So now I have to give George's talk. So from this point onwards, everything I'm speaking on behalf of George. So anything you don't agree, I will note it down and send it to him. And of course, from this point onwards, you will see a very technical talk because that's George's talk, okay? And
I know, but it is joint work, right?
yes, it is joint work, yeah. But he's supposed to come here, and actually, most of the slides he prepared. And then he gave it to me, and I'm trying to. I read it once that I couldn't understand.
Yesterday, Arthur, by the way, I know his parents. He came to conference with his parents. He was not doing any talk there, but then he had a free time, I had a free time, so we basically, Portuguese island, we went around different places. And now I realize that he liked that trip from it, that he came here, he gave his talk. And I think some of that listeners is maybe related to what you're doing.
Yeah, but I'm doing everything on the real line, so I'm going to have L1 space. Okay. Yeah. All right. So how did we get into this? Was because I think since for about 10 years period, George and I have been working on stochastic functions and looking at how to generalize the notion of functional property in the stochastic sense. And naturally, why we want to do that, because a lot of optimization problem becomes difficult when you have non-convexity. So we need kind of more general condition to talk about, how I make a decision with how would be the random response on the other side in my system. And risk analysis is actually one of the perfect place to look into this. But then when we started trying to look at problems where we can apply this, we realized that, different risk is a common topic across many disciplines, and many different disciplines look at risk in a very different way. So for all analysis purposes, we're asking, is there any general representation or general framework to describe risk? So that, instead of looking at one risk measure or one way of modeling risk at a time, can I look at this problem collectively and understand, the stochastic properties I need to obtain certain observations or results. So that was the background. And of course, this talk is mostly on the risk part, not on the stochastic part. Okay. So let's start. You have omega FP, see that's George's style. That is, you have a probability space whenever you have something random. And here we're looking at a risk prospect. Okay, think about a risk prospect being a random variable X. And to describe a random variable, we have three different ways. Either we say X, which is defined on the sample space, right? And or we say Fx, that is the cumulative distribution of X. Or we say at inverse X, that is the quantile function of X. So any of the three are equivalent depending on which angle you want to go and describe your prospect. And yeah, so omega means a sample, okay, sample path. Okay, and you can have a discrete version of it. Again, like in economics, a lot of time we look at discrete finite combinations of risk prospect, and then you correspondingly have, and in economics, we use P, which is the probability mass function, but you can convert it easily to distribution F. Okay, Q stands for quantile function. These are just clearing up notations. So if you look at the three major areas that are related to business that talk about risk, finance defines risk on random variables, because law invariant, and then you look at a measure on the random asset, what happens and all that. Economics defines risk based on probabilities. And insurance often look at quantile. I'll explain one by one, okay? And in finance, we talk about risk measure. And in finance, we talk about valuation. So you think about risk, it's negative of that, okay? And in economics, we talk about relative valuation. That means, the valuation in economics is often not in the absolute terms. Again, this is kind of an overall map. I will explain a little bit in detail. So if you look at, preference literature in economics, this is the typical setup. You say I have, lottery, which means the probability mass function on a random outcome x1 to xm, and therefore a lottery is sitting on the probability sequence, okay? And one thing to notice that, in the von Neumann utility theory, X1, Xm doesn't have to have any numerical order, so they can be dogs and cats or apples, anything, okay? And what we are really comparing is the value of the logger of pressures over different loggers, and they should satisfy some intuitive conditions, for example, completeness, meaning it is a complete order, not a partial order, meaning any two logger I can tell which one is more preferred compared to the other one. Transitivity, if I prefer it 1 to 2, 2 to 3, then one must be more preferred than 3. Continuity, like, if I have 2 algorithms, I can insert something in between, arbitrarily close to one or the other by interpolating into probability mass. And independence, okay? If I add another algorithm, it wouldn't affect the original preference. And with all these conditions, risk valuation, or we call in economics, is utility based, right? So utility function basically says, for each outcome x, it is a value attached to it, which is the utility. And this can be anything again, okay? Dogs and cats, but oftentimes we will assume x is some assets or some value, random variable, and then you will have some shape or functional property, okay? But the framework doesn't really require that, okay? And what we observe is that, expected utility is basically a linear function of the probability mass function, okay? So, so what is, again, this valuation of risk? Is basically valuing each probability distribution and say, what do I gain by taking this lottery, this probability distribution versus the other probability distribution, and the comparison is relative because you can transform the utility function in a Feng transformation. You're not going to change the relative value of this is more preferred than the other. Okay, so this is not an absolute term. That's why it's called relative valuation. Okay, and numerical value doesn't mean much. I say, I have a utility of 20. It doesn't really mean much. It doesn't necessarily translate to dollar values or any happiness index. It doesn't really mean much. It's just a rank. Okay, and no interperson compatibility. I prefer one lottery. It has nothing to do with the match prefer another lottery because we have very different way of practice. Okay. And oftentimes during this framework, if we want to say that someone is more risk averse, the typical way is to say the utility function is contained in X and X is certain value. So that's the typical. Again, this is classical. And in finance, risk measure is modeled. If you think about random prospect X, it oftentimes represents, like a portfolio investment. Now it has a meaning, oftentimes a dollar value. And then how do I measure the risk attached to a random portfolio or opportunity? And now risk measure is essentially calculating what is the position that I need or the amount of capital I need to preserve to cover the potential loss for that random asset. Okay, so it is negative value. And they focus on random variable because is normally invariance, meaning if 2 random variables have the same distribution, then they should have the same risk measure. Okay. And the most commonly talk about risk measure are convex risk measure, and essentially you have to have monotonicity. If the asset is, imagine if I make a bigger investment, I should face more risk. Okay. And second one is cash invariance. If I reserve some cash and add it to the portfolio, it only reduces the total. So it's translation invariant with respect to a deterministic value. Okay. And the most important condition is convexity. And you can see that this is almost like the normal definition of convexity. Only thing that's not R is a function of a random variable defined on omega. So this is a functional. So essentially, we are looking at convex functional defined on the sample space. Okay, and a lot of research in finance looking at different convex risk measure, and why convex risk measure represents risk. Essentially, it preserves what we call, when imagine X has more dispersion, formally we call it larger in convex orders or smaller in concave orders. If the distribution, the asset is not wider distribution or spread distribution are based on risk. So convex risk is more with respect to concave order, stochastic order. Okay. But there are some technical difficulties a lot of times in analyzing this risk. So another commonly used risk measure is for coherent risk measure, and it is any coherent risk measure is convex, first of all. And the additional property is this scaling property, homogeneous property. What it means is that, if I double my investment, then I'm anticipating double the risk. Okay. And the second condition is sub-additivity, which B1, B2 together implies convexity. So that's why that's the case of convexity risk. Second condition, sub-additivity, essentially means that if I diversify my portfolio, and with two portfolios together, I should not increase the total risk comparing to I invest one or two separately. Okay, so diversifying risk portfolio always reduces the risk, essentially. All right, so these are the commonly studied risk measures, and I know you may look at it and say, I use some of them. I think the popular one in our literature is VAR and C-VAR. Okay, some of them are convex and coherent, but VAR generally is not convex and coherent. Another commonly studied risk measure is the linear risk measure with a linear convex score. And I'll talk about that. Okay, in a little bit. Yes.
Simple values are the risk streams, that's the union value.
I totally listed in my slides from your list, but
What are the
yes, written ones. You have
I think it's okay.
I didn't find the 97. Okay. Okay. All right, I have 7 minutes, but very quickly, all the convex risk measure preserves compatibility. Mono only means syntactic compatibility. Just want to have a demonstration. So if your distribution is more centered or more concentrated, then it has higher concave order. Okay, I will use concave order in that. I come back to it. So this is class spread. So concave order means that, if I put any concave function on these two random variables in this expression, then the more skilled one will give you higher. And this is what we want because that's risk. Oftentimes we think about spread as simple like that, but you can have spread like multiple modes and like that. Okay, so that allows you to compare general random variables that have, a different mass distribution around the support. All right. So insurance. So insurance look at nominally assigned risk, right? Like natural disaster risk and all that. So it normally assigns the value to that range of variable because when risk happens, we'll have damage and loss and money to recover that loss. And so it assigns a value to that random variable to ask what will be the premium that I have to pay to cover it, right? And a lot of times in the insurance context, things are heavily correlated or probably dependent. Because if an earthquake happens in an area, insurance will have to pay off your car and your house at the same time. And so the risk often comes are co-monopole risk. That means with the same omega, either you are facing a high realization of your risk or no. Nothing happens, it's low realization, nothing happens, you are coming to your hands, right? And the other important condition is hormone additivity, basically, if you're insured on last one plus last two because of this positive dependence, you are need to cover exactly the value of the premium for last one and two adding up together. Okay, and because of these unique business contacts with insurance, and people have studied mathematics, hormonal additive functionals that are non-invariant and sub-additive, essentially says that we can represent insurance risk in this kind of form, which is the truncated form. And what it is that F inverse, remember that's the compound, which is the representation of the value, and the other part by mu is basically your distorted distribution function. Because I'm taking expectation value will be FU, which is the cumulative distribution. So in insurance, normally you will say, I will put more weights on the extreme event when we have a loss, okay, when the loss value is out. So it's kind of distorted or it's factual representation of risk. Okay. And if we just look at the structure, you see this is the linear functional quantile function. Okay. So, okay. Why I'm saying all these, because different risk measures like in OM measure, we take these results, either take these, okay, utility functions with other risks or financial risks like coherent risk measures, and you can see Suresh there in very recent papers, and or taking people have looked at prospectively and how does that kind of evaluation of OM decisions. And why to pick this topic is because these two papers highlighted here were one of the first papers by Suresh and co-authors. I think the first paper in our area talking about a supply chain coordination under the risk averse players. And they are highly cited paper, and even until today, I think they still spark a lot of interest in terms of how we look at in supply chain context. A lot of times firms may have different risk attitude or risk preference, and how do we look at the supply chain material flow and contracting working under different conditions of measurement. Yes, that's the thesis. And you can see that there's a lot of papers, and here the list of papers are all modeling involving risk in news vendor. Okay, so these are all the lists, a lot. And then there's another paper from Suresh and Suresh recent for CFPT. Okay, so that convinces you this is an important thing. Okay, not really much of application of news vendor as a level, but there's a lot of papers. Okay, all right. So what are we proposing? We are proposing something called full-space risk valuation. And keep in mind that in economics, we have value valuation represented in utility function, which is the linear functional of the distribution. And in finance, we look at complete functionals of random variables. And in insurance, we have linear functionals in quantum functions. Okay. And what we are supposed considering is basically saying that I have a kernel. Kernel is the bivariate function, which is a function of the realization of x, and its probability, essentially. Okay. And when I'm looking at a risk measure, it's basically taking the expectation over both. So, and mostly I work with this quantile form. So with this general bivariate form, you can express the expectation in terms of random variable and distributional quantile. Again, they're all equivalent, but I mostly work with quantile. But if I say W and something inside, I meant the full-space risk measure with the point, which is with the kernel bivariate function. And why are we doing this? Okay, the reason being, most of the well-studied way of modeling risk fall into this framework. And here's examples that if utility theory is obvious because it's a linear functional, and value at risk, which is not convex, not coherent, but it falls into this framework. Conditional value of risk, of course, and then, there are different ones, including omega adjusted valuation, which is used a lot in fund evaluation. Trust me, most of the things that we have studied, form satisfy this, okay? And majority of the form of risk valuation or risk measure takes product. So what it takes is that if U of X is separable in the effect of X or U. And this is intuitive because a lot of times in this situation we find that the patient doesn't help us describe the value. We ask about distortion of either in the value itself or distortion of the perceived probability. Okay. So here's but in general, one may ask that the change in the probability depends on the outcome itself and vice versa. I'll give you a simple example to demonstrate that. Okay. So suppose I have two lottery, and one says with very tiny probability I'm going to earn win $10,000. The other says almost surely and then the other case is that almost surely I'm going to get $10. Second lottery says that with 2% of probability, I'm going to get $14, and with 10 rest of the probability, I'm going to get $10. Which one do you do? Which one? So if you are saying maximizing expected utility, then you can choose the first one. But if you look at the scenario, you will say that is that $10,000 really relevant to me, given that almost surely I'm not going to get it. So when I look at the first risky aspects, I will say my hand is really $10 because that very high return has such a small probability. I'm not expecting I'll get it. So what are we doing here? Because the probability is low and that value is too high, we are actually discounting both the probability and the value itself. So there is an interdependence when we look at evaluation of what value are we looking at and what probability assigned to it. Because if that probability becomes, say, 5%, you will not ignore that $10,000. But because this probability is so low, you will say, why do I bother? I won't get it. Just like, with the forecast that American is common, there will be tornado in the area. How many of us actually go down to the basement and wait for a tornado to get me? A lot of us don't do that because the probability that tornado is going to hit my house is almost zero. So people don't react to such a low probability event, even though the damage can be very big. So this tells us that there is an interdependence between the outcome and the chance of that outcome when we try to look at our valuation.
In Texas, the reason they don't have a basement in the houses because the probability of somebody in this house is only more than the cost of the basement actually exceeds that thing, which is I like the basement. I can afford that. But it's so difficult because the houses are built on a slab. It's very difficult to get a garage actually build the whole new slab. This is like the house. This has to be done right when the house is built. And it is not done because the real estate is itself really. It's not done because nobody wants to pay for the cost of the public to pay the house. But when they go, you want to do that.
Yeah, so because
people buy the figure for $1 million, even though I have no chance of getting it.
that's why individual have different preference. So you can see the same like in your body. Okay, I'll speed up. So, and then in a lot of experimental studies shows that this kernel function in people's valuation are actually not separate. Okay, these are all empirical and or experimental studies. So that's why we need this five-area representation. And very quickly, the properties. First of all, we assume that if random variable isn't almost surely zero, then the valuation is going to be zero. Okay, and And we assume that is, if we assume that this kernel is increasing in the random variable, then we'll have monotone, stochastic larger, gives us stochastic larger. And the second thing is, if, second thing is risk preserving. How do we call W as a risk valuation? Then naturally we will require that W is monotone in the concave form. The risk is more spread, X is more spread, W has less value. And the if and only if condition is that this H kernel function is convex in the realization, and some function. Okay. So this is so I will skip the proofs. And finally, no. Is that? Yeah. So that's the concave board. And finally, if I'm thinking about the risk prospect is related to some decision Y, then I want to ask when is the concave Y so that I can do optimization. And the answer is that, I need the dependence of the risk prospect and the decision Y to be stochastically linear. And I think George has some slides describing what is stochastic linear in midpoint. This is a concept we developed in one of the industry applications in our earlier paper. So all I'm trying to say is that on a very general condition, you can have this concavity if you want to add this. Okay. I think I'm running pretty. So I'll talk about the news vendor model. Okay. So think about I have a risky prospect which is in the form of news vendor model. And someone may say that, okay, K22 UTD campus, if you open up a cafeteria, how much is the business, right? So that's X. So you're thinking about the random revenue. And of course, in order to run the business, you have operational details. You say, I need to prepare food and the operating capacity, but the demand is random. So I may not sell to everything that I'm anticipating, because if sometimes the manufacturer to be too high, I may not meet all the demand. So my my actual sales will be the risky prospect minimum of what I'm planning to serve, subtracting the per unit cost. So this is the cost conversion. Okay. And if I'm thinking about expected profit as my valuation, then I'll have this valuation of this particular business as this form if I maximize it. Okay, as you can see, this is the linear form of the quantile. And if you look at how decision affects this valuation, and you will find that, if I put any risky function, concave function Y on this business to evaluate the risky prospect, so now W is a measure and the news vendor profit is inside my valuation. So this can be a C bar or this can be a trophic equal. So I'm not looking at what I mean is I'm not looking at the expected news vendor profit, I'm looking at news vendor profit as a random variable as my risky profit. And then I'm asking you what will happen if I put a risk measure on top of it. Okay, and then you can easily show that no matter what risk measure you put there, as long as it preserves concave ordering, the risky decision, optimal operating decision, is going to be less than the risk neutral decision. Okay, and why is that? It's because we need to assume H is concave and submodular, which allows us to preserve concave ordering. I think the second thing we need to recognize is that the news vendor profit is actually stochastically linear in the operating decision up to a certain point. Okay, so that comes out nicely. And finally, if I integrate the kernel function and I get X, then this is the so-called fixed asset problem. That means that asset is fixed. There's no randomness. There's no probability on X. Every realization I'll get exactly this. Okay. So fixed SM is evaluated by integration of the kernel. In this case, the relative valuation becomes the valuation. Okay. I'll skip that. It has so much details, and you can define certainty equivalence for this particular risk measure. You can define mean risk valuation for this risk measure. I know it's a lot of stuff, but I'll skip that, and let's go to the functional property. So this is all nice, but then you say, you know, what can I tell about this risk measure? Because in economics, we have a linear functional of probability. In finance, we have a concave functional, and in insurance, we have a linear function. And note that, you know, these properties are not symmetric, because if I say one valuation is linear in the space of probability, doesn't mean it's linear in the space of the other two. Okay. So same thing with concave function. So what happens to our newly defined full space risk valuation? I'm going to skip that, and I think Arthur has talked about race integration. I'm going to use the other one, French's representation too. I think I'm going to skip all that and just go to my result. Okay. So what we know, if and only if characterization is that if you have a valuation that can be represented in this binary kernel form, if and only if this measure is lattice additive in the space of quantile. Okay. Again, I'm looking on the real, so I assume the way many of these technical elements of continuous of the measure and all that. Okay, I assume W is a continuous function again. Okay, and more to that, this result is symmetric in probability space or in quantile space because this is one result. And so this is all nice because we know majority of almost all the risk measurements we have studied in the literature falls into the 5-year risk kernel form. And then we know that they are self-additive, which is very nice property, right? What is not covered? The difficult one is the variance, and one of the probably studied one. So and variance cannot be represented simply in this form. But what can we do with variance? And there's some transformation, and then you will see variance can be represented in an infimum of collection of those kernels. Okay. So if I take a series of H function, the kernel function, indexed by some data, and I take the int of that in augmented those, then I can represent variance. So this means that in the general sense, I need something that covers this. And that way is to do the infimum. Okay. So what we do is to say that, you know, I can look at a more general full space risk representation represented by a collection of kernel functions and taking the infimum of those collection functions. Okay, and interestingly, I can show all the property I have talked about. If I'm only with just a simple kernel. Okay, so without int. What it is that, you know, if this is evaluation for risk, then it should be monotone in concave order. And this is true if and only if it can be represented by a collection of H functions satisfying concavity as a function. So each individual function will have this property. And then I take the infimum, I still preserve the property. Okay, so that's a nice thing about it. And I think same thing with decision making. Okay. So that's it on my talk. So that's what all George wanted to say. And finally, this is my wish to Suresh.